Hello everyone, I'm Dylan the math tutor, and today I'll be explaining how to use trig substitution for integration. This technique can be pretty tricky, but I guarantee you'll be an expert by the end of the video. If this video helps you, make sure to like and subscribe for more content like this. Alright, let's get into it. So when we encounter integrals in sort of this form, something similar to this, where we have this x squared in the denominator with the square root, something that looks similar to this, and we can't use u sub, we can apply a technique known as trig sub. Now, this is a lot easier to explain by example, so I'm going to start off with an example. Let's try this. So see, we have x squared, we have 16 minus x squared in the denominator. So we can't really apply u sub here because it wouldn't really help us. So we have to apply a technique known as trig sub. In order to do this, we have to notice that using classical Pythagorean theorem, this really represents c squared minus a squared equals b. Right, same sort of form, where our 16 is our c and our x is our a, and this whole thing represents b. Okay. Using that logic, a also equals x up here. So in order to solve this, we have to pick a function. Usually it's either sine, tangent, or secant. In this case, it's easiest to apply sine, but not just sine, 4 times sine theta, because our c here is equal to 4. Right, c squared equals 16, therefore c equals 4. Okay? Now if we solve for a few things, if we take the derivative, we're going to get 4 cosine theta equals dx, 4 cosine d theta equals dx. And also, if we solve for theta, we're going to get theta equals arc sine of x over 4. These will be useful for later, so just hang on to those. If we substitute this 4 sine theta in for x, and this 4 cosine theta d theta in for dx, what we're going to get is 16 sine squared theta times 4 cosine theta d theta over 16 minus 16 sine squared theta. Alright. Now to simplify this, we can pull a 16 out of both of these. So something like this. I'll rewrite the top. We're left with 16 times 1 minus sine squared theta. Well, 1 minus sine squared theta, according to sine squared theta plus cosine squared theta equals 1. If we move this sine over to the other side, what we're left with is cosine squared theta. Therefore, this equals 16 sine squared theta times 4 cosine theta d theta over 16 cosine squared theta. We can simplify this 16 cosine squared theta as 16 sine squared theta times 4 cosine theta d theta over 4 cosine theta. Now, if we notice, these are the same, numerator, denominator, these cancel out. What we will be left with is 16 sine squared theta. All right. Fairly simple so far, just some algebra, just simplifying. So this, we need to apply the double angle formula here, which states that sine squared theta is equal to 1 minus cosine of 2 theta over 2. So a lot of trig identities coming into play here. It's very useful to know all of them. This is going to equal 16 times 1 over 2 theta minus 1 over 2 sine 2 theta plus c. All right, so we integrated. We got our answer, but it's best practice to put this back in terms of x. So we can do that in two ways. For this one, we can just substitute this in for our theta. But this one, it gets a little more tricky because we can do that, but we have this 2 here, so things get a little complicated. What I'm going to do is I'm going to simplify this and use the triangle. So the triangle is another component of trig substitution as a whole. So let's sub this in. So we're going to get 1/2 arc sine of x over 4 minus 1/2. Now, another trig identity, sine 2 theta equals 2 sine theta cosine theta. Bring this 2 over. We're going to notice, oh, sorry, this is 1 over 4. This is not 1 over 2. This would be 1 over 4 sine, this will become 1 over 2 sine theta cosine theta plus c. Now this helps us because we can apply the triangle where, going back to our a squared plus b squared equals c squared, we notice that this c, which is equal to 4, is going to be on our hypotenuse. According to arc sine x over 4, well, sine is opposite over hypotenuse. Therefore, 4 is the hypotenuse, and x will be opposite. And then this, according to Pythagorean theorem, is going to be our adjacent side. So, using that in conjunction with these guys, what we can do is substitute them for these terms of x. So I'm just going to rewrite minus 1/2 times, well, sine theta is going to be opposite over hypotenuse, x over 4. Cosine theta is going to be adjacent, which is this side, over hypotenuse, which is 4, plus c. So we can do some simplification here, but this is our answer. If we multiply this 16 through, we're going to get 8 arc sine x over 4 minus 1/2 times x, or yeah, let me do it this way. Minus 1/2, or x times 16 minus x squared over 2. Get that in the frame. Plus c. And this is our final answer. Thank you so much for watching. If you enjoyed this video, make sure to hit that like and subscribe button and leave a comment below of what topic you would like to see next. I hope you have a good day. See you in the next one.